Okay. Okay. Today what we're going to look at is the same thing you just did, but it's going to make more sense because we're looking at a rectangle. Like my garden. My garden outside is a rectangle. I want the maximum space for this, but I want the minimum fencing. Because if I have to pay for fencing, I want to use the least amount of cost, and I want to get the biggest amount of space to grow my garden. But if you see, I have a garden, and I have an area of 80. Say my area is 80. Your garden can look like this. It can look like this. It can look like this. Right? There's different ways I can do this. So give me two dimensions that multiply to 80. 40 and 2. So say this is 40 times 2. I get 80. Look what my garden's going to look like. But look how much my fence I need. 40 plus 40 is 80. And 2 plus 2, I need 84 feet of fencing. So now let's go a little bit different. Let's go 10 times 8. 10 times 8. I know it doesn't fit that thing, but 10 times 8 still gives me 80. I got 10 and 10 and 8 and 8. I got 20 and 16. 36 feet of fencing I only need.
Oh, that's more reasonable.
And I'm going to get a bigger amount of space for them to graze in or grow my garden in. Right? So this is what we're looking at for this. That's what we're talking about when we maximize perimeters and areas and all this other good stuff. So now, let's take a look at what we have here. Where we used to have x and y, that they were positive integers, they still will be because they represent your area, your dimensions of your rectangle. Let's see if I can get this color on. Okay, so now we have a rectangle. Let's all do it the same way. Your length is x, your width is y. So let x equal the length. It doesn't matter, you'll get the same answers, but you'll just get it as a different dimension. And let y be the width. Now, don't these also have to be positive integers?
Yes.
Can they be 0? No, can't be 0. I'll have no rectangle. So we want to graph to find the area. We want to maximize area. So what is it we're putting in our y1? X times y. Isn't that the area? X times y? Okay, this is what we want to maximize. Right now, they're going to tell us you have 100 feet of fencing to use to do this. So let's just lay this out. 100 feet, x and y. So my perimeter is equal to x plus y plus y. True? So can we condense this down? We'll make it 2x plus 2y. Can we factor out a 2, make it a little bit easier? So we're going to make this be the perimeter formula. So perimeter is equal to 2 times x plus y, and area is equal to x times y. Right? Geometry. Now, perimeter is 100. We need to put this, solve for y, and put this into our area formula in our y1. We want to maximize. So is my parabola going opening up or opening down? Down. We want to maximize our area. So how can I solve for y, for this perimeter? Divide by 2. Then what? Okay, good. Now I'm going to take this, and I'm going to put it right in there. Now, when you do that and you distribute that, do you see the negative x squared? That tells you your parabola is opening down. Right? A little hint. Here's my parabola. It stops right down here. Right? What are these called right down on the x-axis? Roots. Good. That's the solution, the roots of your equation. What's the value of y when it's down here? 0. So, if I just took that formula just for tips, and I put a 0 in here. Look, it's going to tell me where my x's go. My x now goes from 0, and 50 minus x equals 0. My x now goes from 0 to 50. Does that help you with your calculator?
I don't get it.
Right? But if your parabola comes through and hits the ground at the x-axis, those are your roots when y is 0. Doesn't that also tell me what my domain is? Doesn't this tell me what x I need? I need from 0 to 50.
We can figure that out though.
Because when we put this in here, your factors, we set y equal to 0.
You can do that. You can set y equals 0 for all of them, and they'll.
Well, for this guy, so we can find our domain.
Yeah, like.
Yeah.
Like for the next one.
We can do that too. It'll just give you an approximate. It'll actually give you your domain. But this way, doesn't that help you put it into your window?
But what if they don't have it?
And then you can use your graph. You can, graph it and take it off your table. You can guess it and see where it turns. So this is the guy we're putting into your y1. So let's go there. So let's put in x times 50 minus x. Now, let's change your window. We said x is going to about 50. So you know what? I'm going to make it 75, just so that I can see the whole thing. What should I make my maximum? My y max. Okay, let's do 100.
No.
Let's do 100.
It does
I
not.
don't know. Let's see what happens. You tell me. Okay. When I do 100, there's one leg, there's the other leg. I can't see it turn.
What is your x-axis?
700.
75? Because if I go to 50, it's going to come right to this edge. I just made it so the parabola would come in the middle of your screen. But absolutely, from 0 to 50, you'll see it.
I recommend 700.
You recommend 700. So let's go with Julia. Julia said 700. That's it. Oh, perfect. So now, can you do a maximum on this guy?
Yeah.
Yeah, do your maximum and tell me what you get. So let's do a maximum. $25. Now, 25 is my x. What does 625 represent?
Area.
The area. Good. That's my maximum area. So now, if I want the dimensions of your rectangle, I know that x is 25. And to find my y, I come back to right here. And I plug it in. So, 50 minus 25 equals y. And y is equal to 25. So here are the dimensions of my rectangle to use 100 feet of fencing and get my maximum area.
So what do we use the 625 for?
The 625 just tells you that's your maximum area.
Oh,
That's all. If they say what was your maximum area, you say 625 using 100 feet.
So we don't really need the 625 for this problem?
So not for this problem. But there might be a problem that says, if I give you 100 feet of fencing, what's the maximum area that you can make a fence around? 625. But if this one's asking for what's your actual x and y, then you give them that. Well, actually, you have to also, no, you didn't have to find your area.
So our x and y is 25.
So your x and y are 25. Now, the next problem, I changed the perimeter to 36. What's the only thing that's going to change here?
The 100.
The 100 is going to go to 36. Isn't everything else going to work exactly the same? See? So now, I could even keep my same screen. It doesn't matter. I have a smaller area, right? So do I have to change my limits on my window? No. I'll still get my parabola to turn. It'll have a smaller area, but I'll get my parabola to turn. Okay. Let's take a look at number 7. This time, I want to minimize my perimeter. I want to minimize my perimeter. So this is the guy that's going into Y1. And what was your formula for perimeter? 2. Good. Okay, We can leave it either 2x plus 2y or 2 times x plus y. Now, I said length and width again. We know our length and width, that it has an area of 64 square feet. So this is given to me. Area equals 64. What's the area formula for my rectangle? xy. So 64 is equal to xy. So in order for me to put that in my y1, I need to substitute out my y.
Divide by x.
Divide by x. You guys got it. So take this and plug this right in there. Now, this is going to give you your minimum perimeter. Is this, because this is a minimum, is this going to open up or down? Up. Minimum. To get a minimum point, it has to open up. It's actually, remember, it's actually a part of your hyperbola because you have a domain restriction in here. The other part's sitting down here in quadrant 4. But we only care about quadrant 1 because you can't have a negative length or a width for your rectangle. So these applications actually make more sense than the other ones. So find me your minimum point. Graph it and find me your point. And if you guys can get it up on your graph there. Could you even use your same window that we used?
Yeah.
Yeah, you could, because this is only a minimum. The maximum's not going to be affected in this, just the x's. But my x must be small, right? Because look at my area. My area is only 64. So 12 times 4 is 48. I mean, my numbers are small, so your x is good. Your window should still work. Leslie, you okay with this? Anybody come up with the minimum? 832. Anybody not get this?
Why is Y one making sure perimeter?
Why one? Because whatever we're minimizing or maximizing is going to go into our y. Because that's the one that we want it to vary until we find the point that we exactly want. That's the one that has to give us our graph. Whatever we minimize or maximize is what we graph. So if we want a maximum, we want to be able to find the highest point. If we want a minimum, we want to be able to find the lowest point. So that's where we have to graph that guy. Otherwise, we'd stand here a very long time trying to find the dimensions of this thing. So when you get your answer, 832, this is your x value. This is your perimeter, your minimum perimeter that you're using. To find your y value, you bring it back to this guy. 64 over 8 equals y, and y will equal 8. And it kind of makes sense because we didn't play with your x and y's at all. We didn't do it times 2 or times 3. If you think about it, a square maximizes that area while it's minimizing that perimeter.
Is it always, are X and Y always going to equal the same thing for these problems?
Well, for these that you don't have like a times 2 or times 3, pretty much, yeah. But if you throw in something else, then it's going to change. But in the long run, they kind of do it. You multiply it by the end. Questions?
No homework, right?
Yeah. Homework is, you finished the other 3 that we didn't finish. Now, on number 8, just a heads up on number 8. Number 8, you're going to put this in your calculator, like it is. However, you're realizing that if you're looking for a rate is very small. A rate's a percentage, but when we put it in your calculator, it's a decimal. So I would take a look after you graph it at your table and look how small your numbers are. Make your window smaller. And your rate can't be negative. Your flow rate won't be negative. So just kind of play with this. This is going to require a little bit of playing with your windows on this. You want to kind of get your window close enough that you can find this point. And the last one is kind of a nice one. You set up what your field is going to look like. Set it up. Draw a picture of it, and it'll help you. Yes.
So, like for number 8, you said F, set F as Y into
You're just going to say y equals, and v will be your x. But it's going to be small. So that's what I'm saying. Be careful in this one. It'll just be small.